Hi students, welcome to preliminary chemistry and the energy topic. This is video number 14 on types of combustion reactions. Now, we've already looked at combustion reactions as being of two main types: complete combustion, which has a large concentration of oxygen, and incomplete combustion, when hydrocarbons and other fuel sources react with oxygen to form water and then a product which is either carbon dioxide, carbon monoxide, or carbon, depending on the oxygen concentrations. Combustions are really any type of chemical reactions where a substance will burn in the presence of oxygen. Combustion reactions may require heat in order for them to reach ignition temperature, although sometimes there's not a huge amount of energy required in order for things to combust. The differences between each of these is how we categorize different types of combustion reactions. So whilst we might still have something that's complete or incomplete, we may or may not have a hydrocarbon fuel source. We also may describe them as being either slow, spontaneous, or explosive, depending on the conditions available and or the substances involved. So let's just quickly look at each of these three. The first is spontaneous combustion. Any substance that has a low activation energy and low ignition temperatures can spontaneously combust in the presence of air or oxygen. A type of coal, which is brown coal, haystacks, white phosphorus, even things like sodium, if you leave it sitting out in the oxygen, are substances which can spontaneously combust. You don't need to add much energy to them. They will just automatically start to combine with oxygen in the atmosphere and combust spontaneously. White phosphorus must be stored underwater, and things like sodium and other active metals are often stored under oil to prevent their spontaneous combustion in air. Slow combustion is something that happens over obviously a much longer time frame. So some substances will oxidize in the air, but they do so extremely slowly. Rusting is one such process. Rusting is, I guess, something we don't necessarily associate with combustion, more corrosion, but we do have a substance reacting with oxygen to produce products. The heat released in such small quantities is so small that even though it's an exothermic, or it can be an exothermic reaction, the amount of energy that's being released is such a small amount over such a large time that it doesn't drive that reaction forward. Fuels like wood and coal can burn slowly due to their small surface area. We can chop wood into smaller pieces to increase the surface area, which increases the rate of the reaction. But if it's a very large piece of wood, then it will burn much more slowly. The combustion will occur as a much slower, controlled process. Coals that burn slowly can also be increased in terms of their combustion rate, again by changing the surface area by powdering, for example. And finally, explosive reactions. Well, these are ones that proceed very, very quickly and accompanied by rapid increases in temperature. And it's this rapid increase in temperature which drives up the kinetic energy of the particles and means you have a much higher proportion of them that will be greater than the energy of activation needed for the reaction to proceed. This addition of heat is going to drive the reaction constantly forward and at often an increasing rate. Hydrogen and oxygen, once sparked, rapidly form water, and this is our pop test. So our pop test is basically igniting igniting hydrogen. We know that the test for the pop test is used for the presence of hydrogen, but that spark is going to ignite the hydrogen to react with the oxygen in the atmosphere and form water. And that's often why you find when you do this pop test in a test tube, for example, you find a lot of droplets of water on the mouth of the test tube, where the hydrogen and the oxygen have reacted with one another. Now, these sorts of reactions are a real problem. Sometimes dust that sits around in silos can combust because of its really high surface area. So if that dust is being warmed, particularly if it's a combustible material like carbon or flour or something like that, then you can end up with quite spectacular explosions or flames as a result of this explosive combustion occurring. This is just one way that we can identify different types of combustion reactions. It doesn't look at them in any specific chemical detail, but it does give you a way of classifying the different ways in which these reactions occur. Thanks for watching.